every single book in the first series of Lightning.
Oh, that makes me want to tell a joke.
There's this one.
In fact, I'm tired enough. I'm going to tell the joke.
The first book and like the first.
What is a woman cat? Most people wouldn't get it, but some people would. I'm not. There was no discussion. It was a joke, and it was a funny joke. It was hilarious.
This was the most hilarious joke in my life. I will never experience such humor ever again.
Jacob would have laughed if he would have heard it. Isn't that right, Jacob? No. All right, let's do some geometry. Bam. Well, that's not bad. Not bad at all. What numbers did we do? You don't have to sound so depressed. You can have a little pep in your step. How much sleep did you get, Jacob? I got 4.5, so I don't even want to hear it from you. No, your voice is complaining though. Inscribed angles, that's not what we did. We did 10-3, right? Numbers 8 through 26, evens, great. Number 8 is 70. Number 10 is 72. Number 12 is 4. Number 14 is 11. 16 is 11. 18 is 42. 20 is 57.6. 22 is 8. 24 is a proof, and 26 is a proof. What questions do we have that are not the proofs to start with?
Could we do 20?
20 we could do. Snowboarding. The snowboarding rail shown is an arc of a circle in which BD is part of the diameter ABC. If ABC is about 32% of a complete circle, what is the measure of AB? Sounds fun. Who is making perfectly arced snowboarding whatever? Nobody knows. But they have to try to relate to the children somehow. And they're like, kids like snowboarding. That's hip and cool. They don't want any stuffy snow skiing. All right. ABC is about 32% of a complete circle. BD is part of the diameter. It's part of the diameter. Great. All right. So, what can we do?
Can we figure out what 30% of a triangle circle is?
32, we can figure out what 32% of 360 is. 32% of 360, 0.32 times 360 equals what? 150.2. 15.2. We're looking for B, measure of AB, so half of that. So, divided by 2, and we get what?
28.8.
There's no way that's right.
57.6.
I don't know what you typed, but it was not that. 57.6 degrees. And we can do that, and we don't have, so this problem is a little bit like head melty, right? Because you're like, wait, but how big is the, it doesn't really ask for how long AB is in linear feet. It asks for the measure of the arc, which means in degrees. And so it's going to be, so that's why we can just do 32% of 360, which would be this length, and then divide it by 2. If they asked for like how many feet AB was, we'd need more information in order to solve it. Any other questions? 8. Shoulder happening to me. Getting old, probably. Or maybe I'm not getting old. Maybe I done got old. Maybe it happened. What do you think, Helen? No, you just stopped paying attention, or else you would have told the joke without me asking for it. I set you up perfectly for a great joke at my expense. And you sat there like a goober. So I knew you weren't listening. That's not funny anymore. Good try, though.
Okay. I guess I'm not funny.
I didn't say you're not funny. I said that's not funny anymore.
Okay, well I guess it's not funny anymore.
It's not. That's what I just said. That's pretty much true. She's not very funny. She's a great person, but she's not that funny. I'm much funnier than my mom. Isn't that right, Stephen? Don't drag me into this. Grammy might be watching.
My grandma's just strange.
You probably think most everybody older than you is strange. Sounds on brand.
Isn't that just kind of normal?
Your mom's mom or your dad's mom?
Bro, this problem is easy.
I didn't.
We're supposed to find x. We don't even need the rest of the letters. So, we are told that this line segment equals that line segment. X is the degree measure here. So, if we were to draw this here, it would be the same triangle over here because these match. If the chords match and the arcs match, right? So, how many degrees is x? 70. Does that make sense? Good. I'm glad. Any other questions? All right. Do we need or want to look at either of the proofs?
For 24, how many steps is it?
24 in the book has 12 steps, including the given. Y'all are like, I did it in 3. Okay, so we clearly need to look at number 24 because y'all are doing some weird proof magic.
Not allowed to use the theorem.
Of course, you're not allowed to use it. You're proving the theorem, probably.
It doesn't say that though. Yeah. It just says write it down.
You can't. You cannot prove the sky is blue by saying the sky is blue.
But we don't know that we're proving the sky is blue.
I would say if you don't know
Guys,
the sky is blue.
Y'all are not idiots. Please don't act like idiots. Why would you be able to say, because the theorem that's in this thing? That doesn't make any sense. Why would that be how you're supposed to solve it? Why on earth would that be how you're supposed to solve it? That doesn't make any sense. What would be the point of the problem if that was how you solve it? Let's do number 24. Y'all do remember what class you're in, right?
It's bisecting. Well, that's what we're trying to figure out, right?
Not really.
You gotta use the given, and then you gotta say JP is the radius, and then you can use it.
But even then, it's only 3 steps. So we're not supposed to use the theorem. Even though it really shows that we don't see it.
Triangles.
Where do we get a second angle from?
What? CPCTC.
No, we have 2 sides and 1 angle, but the angle's not between the sides.
Angle between 2 sides, but not an angle. But the angle's not between the sides. Which we'll look at it and see what you're talking about. We are given that circle P, also that KM is perpendicular to JP. And we are trying to prove that JP bisects KM and arc KM. Okay. What did y'all do? Let's talk about why we can't do it.
We said that JP is the radius, and then used the theorem that said if the radius is perpendicular to a chord, then it bisects it.
Nice. It's true. It's not false. But no.
Wait, do we even have to do anything with triangles? Because we know that angle JLK is 90 and JLM is 90. And that means that arc JK and JM are congruent. And if those are congruent, then the chord would be congruent.
What? So I like the theory that I like, but there's not really a theorem that's you could. This is like the second or third time we've had this moment in this class. There isn't really a theorem that says what you're saying. You could probably write one, but it doesn't really exist. You could probably make that a theorem, but it doesn't. But it's not there right now. So I do like that logic path. That logic path clicks pretty well. Well, that gets you the arc at least, right? Not the segment, but I do. That's better. Okay, so what do we need to do instead? We don't have to prove it's a radius. That's y'all. To be clear, to be completely clear, nothing y'all said was wrong. You just can't do it that way. You can't use the theorem that was given in this chapter to prove itself. because that's what you're doing. That's what y'all are doing.
We gotta do KP, draw out KP and
Yes,
P
yes.
as
That step first. The technical word is construct, but yes. We got to, actually, just kidding. They use draw radii, but construct is a better word. Construct. Radii.
What would be your justification for that? Because you're just like, there's not really
KP
justification.
and MP. So the justification for that is actually, it goes way back to like day one, because the justification for that is 2 points make a line. Right? That's that, because which is way back to like undefined terms, right? But yeah, it's as simple as that. 2 points make a line. So it's even more no duh than a postulate. It's like way, way, way back. Actually, it is a postulate. That's one of Euclid's 3, or is it 7? 7 foundational postulates. I think that's, is it 7? I don't know. I'd have to look back.
Here's where I was confused, because
Okay?
with the two triangles, we have two sides that are congruent and one angle. But that one angle isn't between the sides, so we can't say sine equals sine. So how would we find another angle?
How would we find another angle?
All the other angles are right angles.
The angle KLP is a right angle. That's one, and angle MLP is a right angle.
Is it a 30, 69 triangle?
Is J,
We don't really have any numbers, so we don't know.
is JLM a right angle?
JLM is a right angle. Yes, all of that's true. So what can we say because their radiuses? Let's start with something simple. KP is congruent to MP. And yeah, that's true. And JP, sure. KP is congruent to MP. And we may as well put it on there. We probably don't need it, but. And JP. Because why?
They're all radiuses.
All because all radii are congruent. Yeah. Yeah.
All radii
In a circle. In a triangle. That's right. Great. All radii of a circle probably would be a better way to put it, right?
Now, do we just say LP is congruent to LP?
We would. We
LP
would.
equals LP because it's LP.
Why would we need to say that?
Because if we can get some triangles congruent, then we can get some chunks are congruent, right? So we can get some triangles congruent, then we can get some CPC-TCs up there and be like, this is that, and that's this, and we're finished, right?
You gotta say the parts are congruent to the triangle is congruent.
Well, I was saying things backwards, but yeah, the triangles are congruent, and then the thing, yeah, all the things. Yeah. So LP is congruent to LP because reflexive property.
Would it be different if we wrote it LP is congruent to PL?
Yes. These are in the same orientation on the triangle. If like this triangle was the other way around, Like if it was this triangle, then you would say it like LP is congruent to PL, but they're in the same orientation, so it's more correct to say it that way. That's one of the things that I definitely wouldn't count off for on a test if you like did that part wrong. Unless I was extremely grumpy or something, but I don't know if I've ever been that grumpy before. What can we say now?
Well, we need to say that angle KLP and MLP apparently.
Can we say KM is congruent to, or ML is congruent to MM?
Wait, we did this.
What?
Oh, never mind.
MK is congruent to what? What are you saying?
No, ML is congruent to ML. So then, triangle ML.
It's, ML is congruent to ML, so therefore triangle MLP is congruent to triangle MLP. Yes, we could say that, but I don't know that that's useful because we need this one congruent to this one, right?
How do we figure out LPA when it is congruent to LPK? Yeah, that's
The angle or the triangle?
angle.
Angle
LPM and LPK.
LPM and LPK. Oh, I see.
Or MPL or MKP.
I don't think we can do that. Not easily.
So we gotta use the 90 degree.
Yeah, let's start with using the 90 degrees.
That's what I was
Start with the easy things or easy things.
Can we use a side angle because it's 90 degrees?
That's not a thing.
Sides corresponding. Yeah, no, we got two sides and an angle, but the angle is not in between the sides. Right. It's side angle. Right. So we have to have another angle or the side. If we have the side, then probably that's what you're saying. It has to be another angle. If we're not using LPM, then it has to be LAP.
What lets me say that?
All right angles are congruent.
All right angles are congruent. So we have right now that this is congruent to this. We have these are congruent, and this is congruent to itself. The book is a liar. Because the next thing that they say is that triangle PLM is congruent to triangle PLK because of side angle side. But that doesn't work. See if they put anything else that we didn't have. Let's see. PK is congruent to PM. We have that. PL is congruent to PL. We have that. PLM congruent to PLK. Oh yeah, technically we'd have to put, there's actually a step in between here, right? Yeah, what?
ALP and MLP are 90 degrees.
Our right angles. It's true enough.
The goofy step.
Because of definition of perpendicular lines, yeah?
But I thought we could say something with something because it's something.
I don't know if this problem is solvable. Is there another way to go without using the theorem? Is there something else we're missing? We're not going to spend all day on this. How about 2 more minutes? Is there another way to get there? We could construct this for some reason.
What is that? Is it
It's chord JK and chord JM. We could construct it somehow. Not somehow. We could construct that. It is something like a diamond. It's not something like a diamond, it's exactly a diamond. It's specifically a rhombus, right?
Is it a rhombus?
It's definitely a rhombus. Well, it is. We didn't prove that it is, but it like if these are, like if this is congruent, then these triangles are congruent, right? Because this is,
If it is, then we're still back to where we were because we don't have an angle in between the sides.
yeah. We need to be able to prove, we cannot prove anything about KL and ML. It's let's see, no, side angle. No such thing as side angle.
Is there an angle side?
That's the same, that's same, but no.
What is the side angle side?
Side angle side and angle side angle. Side.
Angle.
No, that's a proof for similarity, but not for congruence.
So there's just 3.
No, there's 4. Side angle.
Wait.
There's got to be a way to prove it somewhere because when the theorem was written, it's in there.
What? So, if it's in the same circle and an arc has the same degree measure as another arc, that means it has the same length, right?
Yes.
And so, it makes an angle in there. And it is
KJ is, but we'd have to know that this angle and this angle are congruent.
Or the other angle, we could do angle.
Wait, so how would we do that though?
That is what we're asking.
I know, but like, there's gotta be a thing with the radiuses if they're going out to the same chord.
We have
We
to
could
somehow
make it
figure
clear.
out that JP bisects.
Okay, so you could figure out that this degree measure equaled this degree measure.
We already know.
And if it's,
And we already know that JL bisects the arc because the 2 angles on each side are congruent. And so if it
But how do you know that the 2 angles are congruent with theorems?
perpendicular.
These lines are perpendicular. But you could have this twisted and it wouldn't cut this in angle KPM in half. Like that doesn't just.
But then we just turn the other 2 radiuses with it.
Well, what I'm saying is you could. What I'm saying is you could have an angle. It's not enough just to say. But you could have an angle out here that is perpendicular. I drew that really bad because I drew that like that one perpendicular. I need it a little less than that. And it doesn't bisect this angle. Like this is not equal to that, right? So just because this is perpendicular doesn't mean this is bisecting.
No, but so if the angles are both 90 degrees, that means that
These ones are both.
And then that means the arcs are both 90 degrees. So that means we know that the arcs are.
This is not. Oh, that's
We
true.
know that they
That's
are
true.
because we know their angles.
That's true. Well,
wait,
no, that would have to be
No, that doesn't work. because
from a.
then
That would have to
says
be
that-
from the radius.
180 because it would be.
Then
would
that
be the
says that
diameter.
JPM is 90 degrees.
Yeah.
No, that doesn't work because it's not from the center.
No. Yeah, it doesn't. It's not. That's what I just said. Okay, that was our 2 minutes. We'll count that as unsolvable temporarily. We'll look it up on our own time later. Let's learn some more circle things. Wasn't that fun? No, because y'all checked out. You know, we still don't, you know, we're in like April 10th, and we still don't understand the point of this class. It's okay. Soon it will all be over. Soon this nightmare will be over, and you don't have to understand the point anymore. Hopefully somewhere along the line we'll get some logic in your brain, and you'll grow up to be a smart, intelligent adult. I bet that happens.
At least not for me, for them.
Is smart and intelligent the same thing? That's an intriguing question.
Yeah.
They're roughly synonyms for at least, if not exactly synonyms.
I mean, people can be smart.
Smart definitely describes less because people say people are smart who are not smart. But intelligent is different. If someone says you're intelligent, that's an innate thing, right?
Is it like a good versus wonderful thing?
Yeah, kind of. Inscribed angles.
Why do you always look at me with such judging eyes?
Inscribed, because he thinks he's smarter than you.
It's like I breathe and he's like so.
Inscribed angles. An inscribed angle is an angle that is inside a circle and its vertex is touching the edge of the circle. There are 3 different possibilities for what an inscribed angle can look like. First possibility. These are all circle P. Great. First possibility is you have one line that is a diameter. Like that. Second possibility is where both chords of the sides of the angle are on the outside of the diameter, so to speak. And then the third option is if we have 2 of them that are both to one side of the diameter. So something like this. All of those are inscribed angles. Making sense so far? Easy peasy lemon squeezy? No big dealio? Good. Theorem number 1. If an angle is inscribed in a circle, then the measure of the angle is 1/2 the measure of its inscribed arc. That's easy money. Let's do an example with that. If you want to see how you prove that theorem, there's a proof for it on page 724 for case 1. You'd have to do a different proof for the other 2 cases. Okay, let's do that one.
Why do you know that that's isosceles?
No, I'm just gonna think about isosceles. I don't understand how you know that.
Because,
ABC equals B plus C.
which one?
Number 5.
APC equals the measure of angle B. APC is the measure of angle B plus the measure of angle C. Because of the because of the exterior angle theorem. Because of
Because it's isosceles. but how
No,
do
it's not because it's isosceles. It's because of the exterior angle theorem. Some of the interior ones, what they really mean, angle AP. Yeah, they said that. The APs. Yeah. That exterior angle equals the sum of the opposite sides. They have the justification sitting right there. I don't know if y'all noticed that. You know it's isosceles because that's what the exterior angle theorem says. You just didn't remember what the exterior angle theorem was, right?
Yeah.
That one.
because the two sides of
Yeah. Isosceles. Isaac Mendez. Y'all didn't ever watch that TV show because it was crappy by the time y'all would have watched it, for one thing. I don't think it ever got as crappy as people say, though. I think it stayed vaguely decent. They just messed up the power creep and then didn't know what to do with it, and so they stupidly nerfed stuff, and it was crazy. All right, so, one more thing. Uno mas, 98 degrees. All right, so we need to find the measure of arc F. CF, excuse me, arc F. What in the world would that mean? We need to find the measure of arc CF. And we'll go ahead and also find the measure of angle C. All right.
What is the angle for D?
What is the angle for what?
What's the measurement for D? Is it 40 or 40?
40. That's a degree symbol. It just kind of like got a little bit shoved in the corner. All right, so we're looking for this one. And we're looking for this one. Right? All right, so what should we do? We should multiply 2 times 40, which will give us CF. Because it's going to be double this, the other way around from the theorem, right? So the measure of CF is 80 degrees.
Well, I thought it was divided.
So what the theorem says is that the angle is half of the arc, right? And so we know the angle, so to get to the arc, we have to double it, go the other way around.
So then would angle C be
So vertical angles doesn't apply here.
49?
Vertical angles doesn't apply in any of the things we're looking for.
Would it be 49?
It would be 49 degrees because it's half of this one. Done. Easy money.
So with circles, you don't use vertical.
You could. Where would the what y'all keep talking about? Enlighten what I'm talking about.
Center of the circle. Moving.
We don't know that's the center.
Oh, we don't?
No.
Yeah, that changes.
In fact, it's definitely not the center. Right? We just proved that it wasn't the center.
That changes.
It does, but we just proved that it's not. Because this can't be 90 degrees.
Yeah,
Actually,
because then 98 moving to the middle would then move to the other side, and instead of 80 for the arc, it'd be 90.
yeah, all the things.
That's what I was thinking, but it's not.
Yeah. Okay. Let's learn another theorem. Slay all day. In fact, let's go ahead and get both of the theorems, all three of the theorems up here, and then we'll see what time we have for examples and go from there. Bam. And also bam. Ooh, that one has a tumor. Let's fix his tumor. And then more bams. Are you saying you're sorry what to the tumor or something else? Oh, you're sorry. You're sorry he has. I fixed it. I cut it off. It's fine. He's all better now. All right. So first theorem says if two inscribed angles of a circle intersect the same arc or congruent arcs, then the angles are congruent. So, something like this.
It looks like a crooked sand timer.
It looks like a crooked sand timer.
Like an hourglass?
Yes. Yes, it's also called a sand timer.
It is definitely also called a sand timer. You two people are making fun of people for no reason. Silliness. You're welcome. I don't understand.
How do you know if
Okay. All right, so what does this theorem tell us about this picture? B and C are congruent. Because this one and this one intercept the same arc. It would also tell us that D and A are congruent, right? Which is not in the book, but it's also true. Easy money. All right, next circle, next theorem. An inscribed angle.
What was the name of the previous one?
The book calls it theorem 10.7.
Can I put that in the justification?
No. I'm not going to go and look up which one was which.
Even if they're all right?
Yeah, no, I ain't going to do that. I don't got time for that. Just write some super shorthand version of this.
two angle equal arc?
Yeah, sure. I probably would count that. That would probably be fine. I would understand that you knew what theorem we were talking about. If you put because obvious, I would be annoyed and count it wrong. If two inscribed angles of a circle What? Oh, I am writing the same one. Steven! You saved me. But you didn't save Gracie. Did you hear that sigh? She was already writing it. With pen. Nope, she's using pencil. Okay. An inscribed angle of a triangle. An inscribed angle of a triangle intercepts a diameter or semicircle. What?
So that makes
Absolute sense? Okay, good. If and only if. One just is the chord and the other one's the arc. It's really, that's just, yeah. You weren't being facetious? If and only if. The angle is a right angle. That's easy money and kind of vaguely obvious, right? That's clearly going to be true. If we have a triangle in here, yeah, because 90 times 2, if we want to use a fancy version. I'm gonna draw it like theirs. I think that is gonna be easier. Wow, that's cute. And then, see, this is why I need my triangle to not be broken. Need to buy a new one. Clearly, what I drew was not actually diameter. Let's try again. Clearly, what I drew now is not a triangle. Great. Good enough. This is perfect. That's what I get for trying. Okay. This is a diameter if and only if. That's a right angle because of the other theorem, right? Because half of 180 is 90. That was, have y'all ever seen in the shirts or the whatever other types of memes where it's like a star or something and it's like, I smile because I don't know what's going on. That felt like that meme. Okay, so if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. What does supplementary mean? They add up to 180.
Because the X makes the
Because the, how do you say this? If you multiply them both times 2, it actually gives an equal to 160.
Yeah, that's true. All that's accurate.
inside a circle, then that means that this one's like half the circle and
Girl. Oh my gosh, girl. Bro.
I would die for every time I said bro.
You know what that tells me?
What?
It tells me. Actually, no, it doesn't tell me that. I was about to tell a lie. Well, no. I don't know. So this plus this, let's see, A, B, C, and D. So the measure of angle A plus the measure of angle C equals 180 degrees, right? Same thing for B and D. Homework. Page, whatever the heck it is.
What does that last thing say?
What? Good. Page is 727. Numbers 12 through oh, I like that problem. I forgot about that problem. It's a fun one. 12 through 36 evens. Even though it looks like it's like Illuminati symbols or some nonsense. But it's a fun problem anyway. 36. It's easy, to be honest, but. All right, that's it. Go find somebody that loves you. Give them a hug. I'll see y'all on Tuesday. Algebra 2 gets to take a really hard test today. It's going to be fun.